Welcome back. You have reached the page of Calculus Conundrums for limits, and we're going to now talk about one-sided limits. Okay, so let me just kind of show you a couple of examples. When we talk about one-sided limits, we're talking about the limit of a function as x approaches a number from the left or from the right. So let's talk about what would happen if you graphed, let's say you graph, let me get my screen where I want it. Okay, let's say you graph this function. So let's look at the graph of this function, absolute value of x minus 1 over x minus 1. Now we know, first of all, that this function is not defined at x equal 1. So we would have an issue there. But if you graphed it, here's x equal 1 right here. So there's x equal 1. And if you look at the graph of this, you can see what you would get is you would get a horizontal line right here, but at 1 there would be no point. And then up here you would get a horizontal line right here, and again at 1, I'm trying to draw a little circle right there, so you would get no point there. Okay, but the question is, what's happening as we go? Be patient, grasshopper. Alright, so what's going to happen here, if I can catch it, there we go. So what would happen here if I approached 1 from the right? Well, if I approach 1 from the right, the y value never changes. Okay, it never changes. It stays at y equal 1. Okay, so that would be this limit. So if you want to talk about the limit of some function as x approaches a number from the right, we put a little bitty plus up there, kind of like an exponent right there. And so that means the limit of this function as x approaches 1 from the right. Okay, now let me get rid of this. And let's say I wanted to approach it from the left. Well, if I approach it from the left, you'll notice the y value never changes as I approach 1 from the left, and so the y value would always be negative 1. So basically what we could say here is that the limit as we approach 1 from the left, let me clean that up for you. Alright, so right here you can see a little negative. That means the limit of this function as x approaches 1 from the left. So that's from the left of 1. And we saw down here that that would equal negative 1. So that limit equals negative 1. And then we saw as you approach from the right, that limit equaled positive 1. Okay? Now, the problem, though, is these are one-sided limits. Let's talk about the limit itself, or if you prefer, you can call that the two-sided limit. The limit itself does not exist, and the reason it does not exist is because the limit as we approach x from the left is one number, and as we approach x from the right is a different number. So since these two one-sided limits don't agree, then we can't say the limit exists. So in other words, the limit itself does not exist. Okay? The one-sided limits exist because we just showed that the limit from the left was negative 1 and the limit from the right of 1 is positive 1. Okay? So the notation that we use for one-sided limits is this: the limit of a function f of x as x approaches c from the left is given by this notation. The limit of the function as x approaches c, and see the little minus there? That means we're approaching c from the left of c. And L1 is just some real number. Alright, now the limit of a function as x approaches c from the right is given by almost the same definition, except notice we have a little plus there. The little plus means that we approach c from the right. Okay, now I'm going to go ahead and show you these limits by looking at the graph. Okay, so let me pull up the graph of this function, absolute value of x minus 3 over x minus 3, and I'll show you how I know that the limit as x approaches 3 from the right is 1. Okay, so here is the graph of this function, absolute value of x minus 3 divided by x minus 3. Notice, here's 3 right here. Okay, you see it? There's 3. So notice, as we approach 3 from the left, the y value never changes. It's negative 1. So we would say the limit of this function as you approach 3 from the left is negative 1. But as we approach 3 from the right, the limit would be positive 1. Okay, but let's see, what did the question ask? I think it just asked if you approach 3 from the right. Okay, so as we approach 3 from the right, remember we got positive 1. I didn't ask for the limit from the left. I could have, but I didn't ask for it here. All right, now let's take a look at this next function. It looks similar, but in this case I have the numerator is kind of switched around here. So let me plot that graph and I'll show you that one. Now let me just go ahead and show you this though before I plot it. We're looking for the limit of this function as x approaches 5 from the left. So the minus means we're looking for the limit as x approaches 5 from the left. Okay, so here's this function and here's 5, and we want to know what happens if we approach 5 from the left. So that would mean we would be coming in along this line, and so as we approach 5 from the left, we would get negative 1. So the limit would be negative 1 there. So that's how I got the negative 1. Now what about this one? What about the limit of x over x minus 3 as x approaches 3 from the right? Let's take a look at that function. Okay, now this graph is the graph of x over x minus 3. You can see it kind of bends down over here and it bends upward here. So what I want to show you is what happens here as we approach 3. Now I forgot which side we were approaching from the right. So as we approach 3 from the right, okay, there's 3 right there. Let me zoom it in so you can see 3. It's not going to show me 3. Let's see. All right, now you can see 3. 3 is right there. Let me back it out because I can show you better. So anyway, this dotted line represents the line x equals 3. I just drew that there so you could see it. Now, watch what happens. The closer you get to 3 from the right, notice the closer you get to 3, the higher it goes up. And so in this case, as x approaches 3 from the right, you're actually going to get plus infinity because it increases without bound. Now I didn't show you the one as x approaches 3 from the left, but if you wanted to let x approach 3 from the left, then you would get negative infinity. Okay, but the answer to our question here as x approaches 3 from the right, and then we would get plus infinity. Now even though I say infinity, since it's not a real number, we still have to realize that the limit does not exist, because for a limit to exist it must equal a real number, and infinity is not a number. Now what about this one, 3 over x minus 5 as x approaches 5 from the left? Let me look at that. Okay, so here's the graph of that one, and here's x equal 5 right here. And so notice as you approach 5 from the left, it decreases here without bound. So it just keeps going down and down. So that would be negative infinity. So there we get negative infinity. And again, the limit does not exist. Okay, let me show you on this one that what happens if you take the limit of this one as x approaches 3 from the left and as x approaches 3 from the right. Okay, this vertical line represents where x equals 3. So now let's say we approach 3 from the left. So as we approach 3 from the left, see how it increases without bound? And then as we approach 3 from the right, see how it increases without bound? Looks like I need to plug my computer in here, but let me wrap this up here. So basically the limit of this function as x approaches 3 from the left is infinity, and the limit of this function as x approaches 3 from the right is infinity. And therefore, again, the limits do not exist, because if the limits equal infinity, that's not a real number. So they don't exist there. So now I want to show you a couple more. Let's take a look at this 2 over x squared minus 9 as x approaches 3 from the left and 3 from the right. So let's look at the graph of that, and here's what you're going to see. Here's 3 right here. This is where x equals 3 right here. Now, as x approaches 3 from the left, see how it goes down? So that limit would be negative infinity, and as we approach from the right, you would get plus infinity. So, as I said, from the left you get negative infinity, and from the right, as you approach 3 from the right, you get plus infinity. But this one also had another interesting x value, negative 3. What happens as you approach negative 3 from the left and negative 3 from the right? Well, let's take a look. Here's negative 3. If you approach negative 3 from the left, you get plus infinity. And if you approach negative 3 from the right, it goes to negative infinity. So from the left, you get plus infinity. And then from the right, you get negative infinity. Now, again, the two-sided limit does not exist, okay? Because these limits are infinity. Well, first of all, they're not equal, and secondly, they go to infinity. So the limit itself does not exist. Even the one-sided limits don't exist. Okay. Now, I've kind of been what some instructors might say cheating on these limits, but let me just tell you another way to do this. Another way to evaluate these limits is to just plug numbers in that's close to the number from the side at which you're looking at. Like for here, if I plug numbers into this function that are to the right of 3, like 3.1 and 3.01 or 3.001, I'll see that all I'll get is the number 1. And so I know that's going to equal 1. Okay. Now on this one, again, plug numbers in to the right of 3. If you plug 3.1 in, 3.01 in, 3.001 in, you should see that the value of the function gets larger and larger and larger. And so that should lead you to believe it's going to plus infinity. Pretty much any time the denominator equals 0 when you plug a number in, then the limit of that function is going to go to plus infinity. The only time it's not is if the number makes both the denominator and the numerator 0, and in that case you get a whole. Alright, so again, you could plug values in. Like for instance, if I wanted this one, the limit as x approaches 3 from the left, I could just plug 2.9 in and see what I get, then 2.99 in and see what I get, and put 2.999 in and see what I get. And what you should see is the numbers should be getting more negative the farther you go. You might get like negative 50, negative 500, negative 5,000, and that leads you to believe that this limit is negative infinity. And then if you plug 3.1 in or 3.01 in or 3.001 in for this one, you might get numbers like 50, 500, or 5,000, and so that leads you to believe this is going to positive infinity. Okay. Now that's all I'm going to talk about on here, but I'm going to continue talking about one-sided limits. But I want to introduce the existence theorem in the next video.